We are going to use this example today to learn how to graph a quadratic function in factored form. This quadratic function given here, we call this standard form. This is standard form. And we have to change it to factored form to be able to find the information we want. Let's start by filling all these blanks. For this given function, first thing we have to ask ourselves is the leading coefficient. Is the leading coefficient positive or negative? This is the leading coefficient. That's our A. A is 1. So we know A is greater than 0. So leading coefficient is positive. If the leading coefficient is positive, the quadratic will open upwards. So let's fill the blank upwards. That means the quadratic will look like something like this. Opens upwards. The first important thing we need to do now is to find the two zeros. We know zeros are also named roots. How do we find it? We need to factor the quadratic and solve for zeros. How do we factor this quadratic? X squared plus 2x minus 3. Because the leading coefficient is 1, we know it is very easy. We can just factor this c. For 3, you can only factor that with 1 and 3, no any other way. And this is negative, so we know 1 positive, 1 negative. And this is a positive 2. We need to plus 3 and minus 1. And here is our 2 factor, x minus 1 times x plus 3. We have to set this to 0 because we are looking for those two x's value that makes y value 0. This is our y. Now we have to use this zero product rule. What does zero product rule means? It says if AB is 0, then A is 0 or B is 0. What does that mean? Zero product rule. Zero product rule says if you have two numbers, A times B is 0, then it is either A is 0 or B is 0. So if we have two factors times together to be 0, like if I have an x plus 5 times x minus 3 equal to 0, we will have either x plus 5 is 0 or x minus 3 is 0. This is called zero product rule. For solving x plus y equal to 0, we have to subtract 5 from both sides. We get x equals negative 5. For solving x minus 3 equals 0, we have to add 3 on both sides. Then we get x equals 3. That's the two x's for this equation. Now let's go back to our document. Earlier we were saying x squared plus 2x minus 3 factor to be x plus 3 x minus 1. And we are setting this to 0. So it's either x plus 3 is 0 or x minus 1 is 0. Then we have to subtract 3. We get x equal to negative 3. We have to add 1. We get x equals 1. That's the two roots we have. So we find our two roots. The two zeros are negative 3 and 1. So these are the steps. Factor the standard form. Then we use zero product rule to solve the two roots. Once we have the two roots, we have to find the x position for the x of symmetry. The axis of symmetry, it is the middle of the two roots. If the two roots are R1 and R2, we use R1 plus R2 divided by 2 to get this x. So here we know our 2x is negative 3 and 1. So we find this middle x position, x is negative 3 plus 1 divided by 2. That is negative 2 divided by 2. That is negative 1. So the axis of symmetry is x equal to negative 1. That is a straight line. That is vertical. After we have the axis of symmetry, how do we find our vertex? Here tells you vertexes. The x is at where the axis of symmetry is. And the y value is plugging that x value into your original function. That's how you find your y value at that vertex point. So the way we do is, we know our x is negative 1 now. So we have to plug in negative 1 to our original function. Our original function is f of an x is that x squared plus 2 times of that x, then minus 3. Now our x is negative 1, so you just plug in negative 1. Then you get square of negative 1 is still 1. And 2 times negative 1 is subtract 2, then subtract 3. We get this value negative 4. So we know our vertex is at negative 1 and negative 4. We got this very important point. The y value at vertex is the minimum value for our case. So this is a minimum. Why is it minimum? Because our picture is like a smile. It opens upward. So you have a minimum point right here. The next important point we need to find is the y-intercept. How do we find y-intercept? Is by plugging in x to 0 to find our y value. So the way we do is, again, our function is f of an x is an x squared plus 2 times that x then minus 3. So we can plug in our x 0, 0, 0. This way, we get 0 squared is still 0. 2 times 0 is 0. And subtract 3. This value is negative 3. So our y-intercept is 0, negative 3. Now we have 3 very important points. That's the 2 roots and the vertex. Oh, sorry, it's 4 important points now with this y-intercept. So these are the 4 very important points so far. You can copy all this down now. Earlier, we already got the 4 important points. Remember that 4 important points first are the 2 roots. So we have our first root, and we have our second root, and we have our vertex, and we have our y-intercept. Now we want to find the last thing, is find the symmetrical point of y-intercept. So this is the symmetrical point of y-intercept. Let's put all those values. Earlier, we found our 2 roots. One is at x equal to negative 3. The other one is at x equal to 1. We know at x-intercept, the y value will be 0. The vertex is at x equal to negative 1, y equal to negative 4. Y-intercept happens at x equal to 0, y value is negative 3. Now let's think, what do we mean by symmetrical point of y-intercept? You think of your quadratic like this. We know the 2 roots is negative 3 and 1. So 1, 2, 3, we have negative 3. We have 1 here. So our axis of symmetry is right in the middle, right here. Now, if we have a y-intercept at 0, negative 3, so it's a 1, 2, 3. This is our y-intercept. So where is the image? The image will be right here. It is this point here, right? If this is a negative 1, this will be negative 2. So we see our point is at negative 2 and negative 3. Everybody see this is the same y value, means they are at the same height. Now you have these 5 important points. We can draw our quadratic now. The quadratic is this way. You can make a y-axis and you make an x-axis and go ahead making the mark. This is negative 1, negative 2, negative 3. We have 1, 2, We know this orange is 0, 0. So now, just put all these 5 points in. Negative 3 is here, and 1 is here, 1, 0. This is my axis at x equal to negative 1. I have a y-intercept point. I need to mark this one, negative 1, negative 2, negative 3, negative 4. This is negative 4, right here. This is our vertex point. And the y-intercept is at 0, negative 3, and the image is here. This is the image of y-intercept. Now we have all these 5 important points. We can draw it now. This is how the function looks like. Function curve. Once we have these 5 important points, we can graph our quadratic function. You can go ahead, do your practice now. Thank you.